So we have at the moment a spacecraft with a mass of 600 kilograms. It is then travelling at 50 meters per second. It is then connecting with another spacecraft of 50 kilograms travelling at 40 meters per second. Now, if both spacecrafts are travelling in the same direction, what you need to do is determine the velocity of the combined craft. So here we've got our first spacecraft. Label this 1. We've then got it connecting with a slightly smaller spacecraft, which we are going to label 2. Both are then travelling in the same direction, as denoted by this arrow. What then, as the question asks, is the total velocity of the two crafts combined together? So what we're going to do is we're going to use the equation for momentum. So we have got momentum is then equal to mv. mv we are going to work out using the principles and the conservation of momentum. This is highlighted in yellow. All then we have to do now is simply attach the known values into this equation, transpose it, we will then get our velocity. So the first thing that we're going to do in any question is we're going to write down the values that we actually know. So in this question, I know that my M1 is 600 kilograms. So I'm just going to label that in here. I then know my V1, which is given also in the question here. So we can write down our V1 as 50 meters per second. So we can then get also our M2, which is our 50 kilograms. And then finally we can get our V2 also, which in this case is our 40 meters per second. So just in this step, I'm not giving you anything new, I'm just simply writing it out, so it's going to be easier for us to work out. So this part then highlighted in pink is then what we're going to work out from our known values. So we're not getting anything new from this part. I can then simply plug these values in to this formula. So if I bring that down here, I've then got 6,000 times 50 plus my M2, which is 5,000, times my 40. Now that is then equal to the known values, which I do have, of my M1 and my M2, of 6,000 plus 5,000 V. Now I don't know V, so that's what we're going to try and find out by simply transposing this equation from the values that we do know. The way that we're simply going to do this, guys, is then remembering how we transpose easier equations. So if I just rub this out, move it across, My answer then to my first part of the equation, so the equals to my momentum, when you put it into a calculator, will equal 500 times 10 to the power of 3. That would then equal, we've got here, 11,000 times V, which is still our unknown property at this point. So the way we're going to get that by himself is, remember, if you want to transpose anything by moving it across, an easy way to remember to do that is we can then simply divide that side by the thing that we want to get rid of. So in this case, we want to get V, this side of the equal sign. So what I'm going to do is I'm going to then divide it by the value that I don't need on this particular side, but we've also got to do that to the other side of the equal sign. So we're going to divide this side also by 11,000. Like so. All we have to do is then cancel the parts that occur on both the top and bottom of the divide sign, because they cancel out. So here I can now cancel out that and this because they both occur. On this side I haven't got anything that occurs on both of them, so I can leave it as it is. This is great because then we hopefully will get V just by himself. So the answer to V now is just going to be 500 times 10 to the power of 3 over 11,000. Answers are V. So that's how we're going to work out V. If you then put it into a calculator, you will then be able to get our answer of 45.45 meters per second. And therefore, guys, we have now answered our top question. If I just move that down. For if both spacecrafts are travelling in the same direction, determine the velocity. This velocity is then of the two crafts combined. So remember, we had those two areas. So R1 and R2. That is then what we are now going to call my arrow.